Okay, welcome to our second class for the circles unit. Today's topic, properties. You will find it on page 384. Properties of tangents to a circle. I touched a little bit on tangents in the introductory lesson. Properties of tangents to a circle. Let's begin. The title written down. Let's begin our lesson with drawing a circle. I'm not going to muck about with a protractor this time. We're going to make a radius. Okay. Thought I had a ruler here. I do. We want to know where the middle is. Horizontally, 9.5. So the middle is about 4.75 horizontally. Vertically, also 9.5. So this is the point where the middle is. So we've made a radius now. I think I found the middle fairly accurately. Maybe you'll do a better job, but I think I'm pretty close. I think this is better than decent. Now our next bit of instruction on page 384. Draw a line that touches the circle only at the end point of the radius. This is the beginning in the middle. This is the end here. Touches the circle only at the end point of the radius. This straight line. There we have a tangent. Measure the angle between the radius and the line. I don't need to. It's a 90, but you can if you like. And repeat the previous step for other radii, the plural for radius, and lines that touch the circle at the end point of a radius. Record your results. So let's, now that we know the middle, it becomes relatively easy to just make multiple radiuses. And for each one, we'll make a tangent. What do we observe? Write a statement about what you observe. So this line is a tangent, this line is a radius. Where a radius, let's just say this. Where a radius and a tangent intersect, they form a right angle. They form a radius and a tangent intersect. They form a right angle. And no, we're not going to repeat the procedure for other circles. This is a consistent rule. We don't need to do anything further with it. Let's have a look at page 385, where we'll read more information about a tangent to a circle. But this is basically what it is. Here's your radius. Draw a line that intersects the radius. It's always going to make, the two of them are always going to make a 90-degree angle. And here's another example of tangents. Imagine fixing one end of a ruler and rotating the ruler across a circle. Then you would make multiple lines like this. And then where the lines meet here, see, outside the circle like that. As one edge of the ruler sweeps across the circle, it intersects the circle at 2 points. Just as the ruler leaves the circle, it intersects the circle at 1 point. The edge of the ruler is then tangent to the circle. So we have a whole bunch of points of tangency happening here. A line that intersects a circle at only 1 point is a tangent. It can't intersect like here. It's coming across all the way, so it's intersecting twice, so it's not a tangent. But if we look at it here, if the lines only went from here to here, then that would be a tangent. Okay? If they're intersecting twice, it's not. So a line that intersects a circle at only 1 point is a tangent to the circle. The point where the tangent intersects the circle is the point of tangency. And here we have an example. Point of tangency, tangent. I don't think we need to sketch this one. Clear enough, right? There we have a tangent, and the point where the tangent touches the circle is the point of tangency. And it's any line outside the circle that touches the circle only once. It can't go through the circle like the above examples do. Let's look at our little brown definition box on the bottom of 385. Tangent radius property. The tangent to a circle is perpendicular to the radius at the point of tangency. Perpendicular simply means that two lines intersect to form a 90-degree angle. As we established in the opening activity, that's what happens, and that's what perpendicular lines are. So here we say that APO is and APB make a 90-degree angle with each other when they come together. This is 90, this is 90. In both directions, it's a 90-degree angle. And that's what happens every time a tangent intersects a radius. That's basically the only thing you need to know from the lesson so far. A tangent is a point on the outside of a circle that intersects the circle only once. And whenever a tangent intersects with a radius, they form a 90-degree angle. Just those two things. Let's move along. We're going to do several examples. Do it like this. Here's my sheet. Point O is the center of the circle, and AB is a tangent to the circle. So in OAB, AOB equals 63 degrees. So the center of this circle is 63 degrees. Okay? Determine the measure of OBA. OBA. We're trying to find the measure of this angle up here. Now you might think this is hard. It isn't. This is a radius. This is a tangent. So what is this angle here? You should realize it's a 90-degree angle. So, page 386, example 1. 180, take away 63, take away 90. And what do we get for the measure of OBA? 27 degrees. Angle OBA. Forgot to show you what I'm doing here, sorry. 180, take away 63, take away 90 equals 27 degrees. So angle OBA equals 27 degrees. You have to know that that angle, that is the angle of an intersection between a tangent and a radius, is 90 degrees. You got to know that, and then the rest of the math is not that hard. Page 386. Example 2. Point, here we are. Point O is the center of a circle, and CD is a tangent to the circle. CD is 15, OD is 20. Give the length of CO. So this is a 15, this is a 20. Once again, we have a radius here and a tangent here. So this angle here is a 90-degree angle, and as long as a triangle has a 90-degree angle, what can we use to find unknown sides? Pythagoras. A squared plus B squared equals C squared. Right. So we're looking at the short side here. We know that this is the long side. So we're looking to find the shortest side. So we know that we will be subtracting here. We're trying to find side A. So 386, example 2, A squared plus B squared equals C squared. A squared, I forgot the numbers, hang on. 15 squared and 20 squared. How do I do this? A squared add 15 squared is 225, 20 squared is 400, and to find A I have to subtract 400 minus 225. Gives me 175, and my final step is, of course, to find the square root. 13.22. And let's see if we're correct with that one, or if I'm correct. Yeah, 13.23. So the radius of the circle is about 13.2 centimeters long. Close enough, isn't it? All right, let's have a look at the example on page 387, right across here. An airplane, A, is cruising at an altitude of 9,000 meters. A cross-section of the Earth is a circle with radius approximately 6,400 kilometers. A passenger wonders how far she is from a point H on the horizon she sees outside the window. Calculate this distance to the nearest kilometer. I think we'll do this example by making a sketch. Make the circle over here, and then we'll do the math beside it. Let's get the full circle on the page here, folks. Find the middle again. It's the same circle as before, so I think I can make a little less fuss and just say, here's the middle. And here we have 6,400 kilometers, and here we have 9,000 meters. And we have this part intersecting the circle right there. And it's saying this here is a radius as well, right? So if this is 6,400, this is a radius, 6,400 kilometers. This guy's a radius as well, so he is going to be 6,400 kilometers as well. So you got to recognize that. This guy coming down here is a tangent. So you have a right angle right here. So how do we do this? We're looking for the length. The plane's up in the air. She wants to know how far she is from the Earth. And apparently she needs trigonometry to do that. She doesn't have a digital measuring device that will tell her. Well, first of all, this is meters, this is kilometers. So for our long side, we got to make these measurements jive. 9,000 meters is how many kilometers? 1,000 meters and a kilometer, that's 9 kilometers. So you can put it together with the 6,400. 6,409 kilometers is our long side, our side A, C. 6,400 is our side B, and side A is our unknown. A squared plus B squared equals C squared. A squared, B squared is 6,400 and squared, and 6,409 squared. Right? Because that's the 9 is the 9,000 meters, that's 9 kilometers, 6,409 for the long side here, and 6,400 is just a regular radius. Of course, this is a radius as well, but we've attached the additional height of the plane, which is 9,000 meters. So let's do 6,409 squared, 41,075,281 und 6,400 40,960,000. Dealing with big numbers, but yeah, we dealt with that before. Subtract the two numbers from each other. $115,281, and of course our last step is to find the square root of this. $339.5. 339.53. She is pretty much 340 kilometers from the horizon, this curious passenger. How the cuss she would get those numbers to make that calculation, I don't know. But I guess we just had them here and we did it. Alrighty, that brings us to your homework on page 388. Let's give you what the questions are, and then I'll go over them. This one is not handed in for marks, but the previous one that worksheet with the circles, diameter, radius, all that stuff, that is handed in for 10 marks. This stuff here is just for practice. 388, 3, 4, 5, 6. If you want to know that your answers are correct, you can by all means give them to me. But by the way, this is not a difficult lesson at all. And these exercises will not be hard to do. So write this down. Page 388, 3, 4, 5, 6. Screen's freezing. There we go. Page 388, 3, 4, 5, 6. And page 389, 7, and 8. Let's go over those. In each diagram, point O is the center of each circle. Which lines are tangents? If you can't do number 3, it's a non-starter. The line on the outside of the circle that intersects the circle in one place is a tangent. And all you have to do is name it. In the first case, it's OPR. Point Q is the point of tangency, where the tangent touches the circle at one point. Point O is the center of the circle. That means that this line here is a radius. So what's the value of each D? I hope you're not thinking too hard about this one. I hope not. Aha, here. Point P is the point of tangency and O is the center of the circle. So this is a radius. Determine the value of each x. They're all unknown angles. This one ought to be obvious, I hope. Here, have the unknown here, but we should know that this one is a 90. And then just do the calculation, subtracting from 180. Same thing here. We should know this is a 90. Calculate 180 minus 47 minus 90. That's question 5. Question 6. Point P is a point of tangency and O is the center of each circle. So number 6, these are Pythagoras questions. This time you're doing the long side. A is 3, B is 4, C is your unknown. You're going to be adding because you're finding the long side. And do these properly. You know how to do them. (13, 5). What's our unknown side here? B, the middle side, right? So 5 squared plus a squared equals 13 squared. This time you know the long side, so you're subtracting. Here again, you know the long side. The other two are 15 and 25. 3 Pythagoras questions for you, which you did a ton of in the previous unit. And there'll be a big part of this unit, inscribing triangles into circles. 7. Point T is a point of tangency, and O is the center of each circle. Determine each value of D and E. If you take a really close look, and considering this is a radius, so it's going to cut things down the middle, you should see that this becomes relatively simple. There's 90-degree angles here, there's a 28 here, right? A 28 here, a 90 here, how do I find this one? A 35 here, a 90 here, how do I find this one? Bang, done. Here, we're looking at E. There's a 69 here, a 90 here. How do we find E? A 33, a 90. How do we find D? And bang, bang. 8. Point S is a point of tangency and O is the center of each circle. Determine each value of A. This is the same as 6. Honestly, it is. Go back to your homework list and cross out number 8. It's the same as 6. So your homework on 388, 3, 4, 5, 6, on 389, just number 7. You leave it there, a little more than a 25-minute class. Au revoir.